G'day. Today's part is just a stepped washer made out of steel. There's a drawing of the part there. The material is S1214, which is a free cutting steel, which is quite nice to work with. There's the drawing I did to create the DXF to take into the CAM part of the Hercus software. And here it is, the software. We'll do a simulation in single steps so that I can talk through it a bit better. When I just let it run, it's impossible to give much of a commentary on the actual simulation. I'm using single step simulation, but whenever the simulation includes a CAN cycle like this stock removal, or a drilling cycle, or a threading cycle, it will finish that as one move. Now we're going around the profile, just finishing the turning. Then you'll see the drill will come in, and again it will stop, and then it will go right through the drilling cycle like that. Then it comes back out, then we wrap it in, and just a very small move to the corner there to break the sharp edge. So that's the drilling done. Now we use the parting tool, go in a little bit, come out, go across so we can create the chamfer, and then go in a single move. No pecking, I've given that up. So that's what I was getting when I was pecking. It's one of the reasons I don't do it anymore. I'd slowed it down because I was still using the drilling speed. So when I started getting results like that, I sped it back up to the turning speed of 2500 and used I think 0.03 per rev feed for the parting tool, and I got much better results, which you'll see at the end of the turning. This is the stock removal cycle. You can see it's chipping quite nicely. The material is coming away. That's an FC ground insert, which I think has 15 degrees of rake. It's a CCGT 090308 FC is the Sumitomo specification for it. That's just the end of the CAN cycle. Then we go back and face it off the length, and then do the profile. And this is all following the DXF that I'd created in CAD to give me the various toolpaths that I wanted. Right, then we slowed down to 2000 RPM, which is the recommended speed for the drill. The recommended feed is actually 0.1 per rev. My Z servo won't push hard enough to get that done, so I had to slow the feed down. There was the drill just breaking the sharp edge. Sped back up to 2500 using my Kennametal parting tool, and you can see it's just going in there. Chips are flying out of that slot quite nicely, and that's it done. And that is the finish I was looking for, not what I was getting before. I mean, to me that matches a turned surface. It's just brilliant. And that's the other side of the turned part. So thank you for watching.